Let's look at the 6 trigonometric functions and how to define them. Trigonometric functions look at the angles of a triangle and evaluates them based on the sides of the triangle. So let's suppose I have this right triangle and I have my angle theta. We call this short side attached to theta the adjacent side. The side opposite to angle theta is called the opposite side. And the longest side, the one across from the right angle, is the hypotenuse. And we define our trig functions based on these. So if we have 6 of these, the first is sine of theta. This is denoted, it has an abbreviation of sin of theta. This is given by the length of the opposite side divided by the length of the hypotenuse. So we say opposite over hypotenuse. We also have cosine of theta. This is the length of the adjacent side divided by the length of the hypotenuse. We have tangent of theta. This is the opposite side, the length of the opposite side divided by the length of the adjacent side. For cosecant theta, we have the length of the hypotenuse divided by the length of the opposite side. For secant of theta, we have the length of the hypotenuse divided by the length of the adjacent side. And finally, for cotangent of theta, we have the length of the adjacent side divided by the length of the opposite side. So these trig functions just look at the ratios of the different sides of this right triangle. As a quick reminder for the Pythagorean Theorem, if I have a right triangle and I call the legs A and B and the hypotenuse C, the Pythagorean Theorem says that a squared plus b squared is equal to c squared. And I just want to point this out because I will be using it to look at some different triangles and their trig functions. Let's look at this triangle here. We have that the legs are length 3 and 4. We know this right here is our angle theta, and we're missing the hypotenuse. So the Pythagorean theorem says if I square each of the legs and add that together, it's equal to the hypotenuse squared. So this is 9 plus 16 is equal to c squared. Or 25 is equal to c squared. And taking the square root, I get that c is equal to 5. So the third side of this particular triangle is 5. And I want to go through all 6 of my trig functions. So the sine is the opposite, which is 3, divided by the hypotenuse, which is 5. Cosine is equal to the adjacent, which is 4, over the hypotenuse, which is 5. Tangent of theta is given by opposite over adjacent. The opposite is 3, and the adjacent is 4. Cosecant was given by hypotenuse over opposite, so we have the hypotenuse, which is 5, over the opposite, which is 3. Secant of theta was given by hypotenuse, which is 5, over adjacent, which is 4. And finally, cotangent is given by adjacent over opposite, so 4 over 3. So I now have all 6 of my trig functions. What about this triangle here? Theta is this little angle at the top here. The Pythagorean theorem tells me if I square one of the legs plus square the second, I get the hypotenuse squared. For this triangle, that means 1 squared plus b squared equals 5 squared. So this tells me 1 plus b squared is equal to 25. I can subtract 1 from both sides to get that b squared must be equal to 24. So b is equal to the square root of 24. We can write 24 as 4 times 6, and we know the square root of 4 is 2. So this is 2 square root of 6. So if I look at sine of theta, sine is opposite over hypotenuse. So the opposite is 1, the hypotenuse is 5. For cosine of theta, I have adjacent over hypotenuse. So 2 square root of 6 is the adjacent over the hypotenuse of 5. Tangent has opposite over adjacent. So the opposite is 1 and the adjacent is 2 square root of 6. And when we have a square root on the bottom, we multiply both the top and the bottom by that square root. 1 times the square root of 6 is square root of 6. The square root of 6 times the square root of 6 is 6, times 2 is 12. So this is the same thing as the square root of 6 over 12. Cosecant of theta is equal to hypotenuse, which is 5, over opposite, which is 1. So this is just equal to 5. Secant of theta is equal to hypotenuse, which is 5, over adjacent, which is 2 square root of 6. Once again, I multiply both the top and the bottom by square root of 6. The top is now 5 times the square root of 6. The square root of 6 times the square root of 6 is 6, times 2 is 12. So I have 5 root 6 over 12. Finally, cotangent of theta. Cotangent is adjacent, which is 2 square root of 6, over opposite, which is 1. So this one is just 2 square root of 6.